metric paper. It's the only type of paper that we use that can, when folded, will create the exact same shape. Letter paper, when you fold it, new shape. It's even if you do it in half. Origami paper, fold it into a different shape. So, metric paper is special. So it's round down from an average piece of metric paper to the smallest thing in the world, down to the observable universe. All is in a single sheet of metric paper. Well, not actually, because you're going to have to get 1 million of them and have to be able to fold it that tiny, which would be impossible. Possibility, so annoying. But let's just imagine it for now. Let's start at the current size of our metric paper. Fold it in half, and then fold it in half again, and you get the size of an average insect. Get to the insect's organs, down into the DNA, and then to the platnik, aka the smallest thing that we ever knew about, which means that it's smaller than that. That is about the size of a bee's organs. So a platnik would basically be this times infinity. So that's not good. We won't be able to measure that pretty well. Okay, let's make it even further. Now, standard piece of metric paper, got it? Double it, it becomes the size of your desk. Double it, it becomes the size of your room, but I can't do it here because it's only 16 meters. 16 meters can't really measure the entire observable universe, which is about 1 million light years times infinity. So let's just do our best to imagine it. Fold it again and you get the helm. Fold it again, you get a street. Fold it again, you get a city. Fold it again, you get a country. Not that big. Now, a country is not exactly alive, but there are people living in it, so it's basically a colony of ants. So yeah, but that's still not big enough. Now, just remember about the speed of light. You might think that light is extremely fast, but I'll show you something crazy. Just wait a bit. Fold it a couple more times and you get the size of Earth. Fold it a couple more times, you get the distance between Earth and the moon. Now, there are currently panels on the moon that collect information from Earth, which works by sending light beams, which is reflected back into coded messages. So, and then we can see the light. If we can zoom in to see the light, it's even slower than this. It would be more like, takes about 1 second for the light to get to the moon. Really slow, actually. So if you're thinking that light is extremely fast, metric paper proves you wrong. Or at least just looking at that area. But okay, let's just get a bit bigger. Even more, we get the Earth in the center, Mars over there, and Venus over there. And then even more, the sun would be right where that tree behind the camera is. And then you get the entire solar system, the Oort cloud, the entire Milky Way galaxy, and then the entire cluster of galaxies that we live in, and then the observable universe, which is the most that we can see. We haven't seen anything bigger than that. And we can have access to that in a single sheet of metric paper. So metric paper truly is a miracle that it exists. So if you want to find a piece of paper that can prove everything, just one artifact that can become the biggest thing on Earth, in the universe, get a piece of metric paper, and you will find that that single sheet unlocks a whole universe of sizes and shapes, from the smallest thing to the largest universe. All that is successful with a single sheet of metric paper.